Bismillah ar-Rahman ar-Rahim. Today we are going to talk about last lectures in analytical geometry. It will be the last conical shape. We are going to talk about hyperbola. That hyperbola is a curve you draw a point moving so that the ratio between the distance from the focus to the directrix is fixed, and greater evidence of that integer 1 means if we look at that conical shape, and already we study circle in a secondary school, then start in that course with Cartesian. So we talk about the parabola, then ellipse, and today we are going to talk about the hyperbola. All these shapes we talk about it, and if we look to the ellipse shape, is a closed oval shape. If we cut that shape and we put both vertices opposite to each other, so we will get what is called hyperbola curve. Hyperbola curve, it has two vertices and two foci and two directrix line, dr and d dash r dash, and we have here a and a dash, s and s dash, and also we have the chord which is a column perpendicular on the x direction, the passing through the focus of that shape, similar exactly to what we studied on parabola and ellipse shape. But in ellipse shape, it was that closed oval shape, and in parabola we study only half of that part. In hyperbola we have two opposite shape for the parabola shape, or we cut that ellipse to half and we make it opposite as a mirror, as we see that y-axis make as a mirror. So when we look about this one here, so we found that one it will be opposite in direction. Okay, let's see our ellipse equation. It was in that form, and that what is studied in the ellipse face shape, and it was x squared over a, which a is a maximum axis, and y squared over b, and b it will be the smallest one or smaller one, equal one. That means we are similar around x and that long axis. If we interchange that b it will be here and a it will be here, that means y it will be our axis. Now x is, we in the general face, in the general form, x is our main axis, and b there is a relationship between a and b, and we got that relationship which talk about that b squared may be equal a square 1 minus e square, which is foci distance, the focus distance. This our general form for the ellipse one. Okay, let's see what it will be our talking about here. In case of hyperbola, e greater than 1, so this one it will be negative. If I put it here, it will be negative because this one greater than 1. So in order to make b real, in this case we should put that e square negative 1. So the first change in the ellipse 1, that we change this the relationship between a and b, that we e will be greater than 1, so we are going to interchange e instead of 1 and 1 instead of e to be positive 1. So that's what we have here in the hyperbola. That's the first change. Second, so it will be, once we put it like that, so the sign between both of them, it will be negative here, and our general standard hyperbolic equations becomes like that. So see what is the difference between that one and ellipse 1. So ellipse 1, it was positive, and to get a hyperbola, it will be negative. So that one, it will be positive, and this one, it will be negative 1. That's the difference between both of them. So both ellipse and the hyperbola, similar equation. We have largest x axis, the distance of that it will be a, and y-axis, the distance of this axis, it will be, and similar exactly whatever have here, similar to that one here. So if we talk about the symmetry, we conclude that hyperbola has two foci and two directrices. Hyperbola forces are 2 points, negative and positive, and both of them on x. So y should be 0. But we have one right side of y and the other one left side of y. So our directrices respectively, it will be x negative a over e and x positive a over e. So that the distance, our corresponding directrix respectively. So this will be the distance of directrix from the vertex. One of them have distance a over e, and the other one negative a over e. Okay, see, so what I'm talking about here, see that one directrix and the second one, and this y and whatever inside that side, mean right one, it will be positive, and the other one it will be negative. So D have distance from y, I mean dr, it has distance from y a over e, and the other one negative a over e. Now we need to get the difference between the 2 points on hyperbola of his two foci. Suppose that we have that s and s dash, and we have here point there on that hyperbolic curve in positive 1. See, we have here bs, and we have here bs dash, and we have here bd dash and bd. So if we look bs dash and bd dash, we will get e, first one. So the ratio between bs and bd, it will give me e, the foci 1, focus 1. So we can get that bs equal ebd dash. Similar exactly if we look the other side in the positive one, so we see that bs and bd, and we will get that value. Now we wanted to get the difference between both of those, bs and bs. S dash. What is the difference between both? For example, if we see that I want to see to show you something here. This one, see, whenever you move on one of that or one of that, similar distance from the focus, but focus doesn't change, but both of those lines are changed with constant difference. That's what we need to get it, because whenever that getting long, so the other one it will stretch and the other one stretch, see, but still the difference between both of them is fixed. Let's see what I'm talking about. We need that one, right? See, I want to get BS dash minus BS. That one I need. What I need, that one minus this one. What will be the difference of both? Of course it will be that one minus this one. So see what I'm talking? Yes, here I get the common factors E outside and it will stand B dash minus BD. Okay, let's go and continue. Of course that means that this one, what I'm talking about, it will be the distance over there. So I have this distance, what is called B dash, okay, and the other one it will be here the other distance BD. So this one it will be BD, that one, okay. So if we look like this, what it will be the end of this subtraction? Now we have subtracting what BD dash negative or minus BD. Okay, the rest will be, of course, in that case it will be this distance, which D dash. So DD dash here, so that term became that term, okay, from here. Okay, look at this one. We have A over E in one of them in a positive one and another one in a negative one, but we're going to take as the absolute value of this. So we have how many A over E? 2. This one. Now if we take that one and put it instead of D dash, we will see that E dash goes with that E and it will be that the final end. So the distance or the difference between BS dash minus BS, it will be equal to 2A. So that's the first proved. Okay, the second one, we need to get the length of tangent perpendicular focal length. What does it mean? Does it mean I need to get that line which passing on that focus and it has L dash as a cross section and passing through LS. So what we're talking about, that the vertical hypotenuse is L dash SL, means this point and this point and this point, all that line, and coefficient of x of point L, that L, this one, has distance AE. Okay, so I can substitute x with that by substituting the hyperbolic equation itself, so we'll find that instead of x, so we are going to put a square e square over a square negative y dash, so that means this part it will go with this part, so it means e square equal like that. So if we look at the y dash, so right now it will be like this, that b e minus 1, so it will be b square over a square. So ls square will be give me this one, or y squared will be this one. Okay, of course. So if we see ll dash, that means 2ls, of course, means this all equal that part plus this part, so 2 of them, so it will be like this, right? Okay, so once we have it like this, this one, small one, have b square over a, so that will be 2b square over a. Okay, let's have example. This example, write equation of hyperbolic. We know that equation of hyperbolic, that means x square over a square minus y square over b square equal 1, right? That's the general form. So we need to change this one to that. Means, so you are going to divide by 144. 144. So I will divide all that to change this one, and I will get a and I will get b. So that is standard. And then I will get cutter's axial length. I need the cutter axial length. I need the facility, the companion. And I need the length of the column focal length, that means the tendo. And I need to get the coordinate of the focus, or the focus, the two focus we have. So we need 1, 2, 3, 4, and 5. For the first look, for that one, we conclude that they're very complex, but it's so easy to get all of that. Let's see. First, we divided by 144, so that's our general equation. To get the cutter axis, we know that the cutter axis is 2a. From what we have done top, what it will be the a? It will a from here, get the square root of 16, it will be a 4. So a equal a, it will be, so and I want to give a, it will be 4. What it will be, b it will be equal 3. So now I have a and b. So from here I will get the cutter length, the cutter axis. So as a companion one, it will be function of b. So b equals 3, so it will be 6. See, up to now we get three things. I have here 1, 2, 3. What's left is the focal length and the coordinates. See what I'm going to get. Oh, the length of the focal comes from 2b square over a. So 2 9 over 4, it will be 9 over 3, 2. And finally the companion relation, that's what we have, which is interchange between 1 and E course. If I'm talking about ellipse, that means it will be here, and that one it will be there. So it yields that 9 over K. So E equal 5/4. So I get 5/4 from here, include the difference, central difference of E. Okay. So our focus points are 2 points plus or minus A of E. So it will be 5 and 0. Okay. Let's see the hyperbolic equations whose axis is parallel to the two axis coordinate. Means that I'm going to move our point original one, which O to another two coordinates here to alpha and beta. That means this not our original one, and our hyperbolic curve, it's not going to bat on that original, but it will bat on those new one. So that our new directrices, and these two vertices and these two foci, and all change from that point to this point, move from that point to this point. So it will be something like that. So right now I'm having AE will move distance alpha, and Y change from that place to this place, and this one it will move from that place to this place. So this one it will be different from that one. So all of them change. So even our directrix, both of them change the equation of it. See, change it here. So here increase by alpha, here increase by alpha, and here is increased by alpha, here increased by alpha, and this A, B, and C. Okay, so new value for our equation, it will be x minus alpha square over A, y minus beta square over B square equal 1. That means if I want to ask you how much it will be the x or how much be the y, so if I give you alpha and I give you beta, so you will get our original axis. Okay, let's see this equation. Right now we have this equation, and we want to get the length, the center and the length of the axis of the hyperbola. So we need to get the general equation first. To get the solution, suppose that our equation like this, so we are going to minimize that one to be just only with x square and y square. How it will be like that? Here, look, we have x square and we have x, and we have y square and we have y. So we have that constant one. First, that one we want to move it outside here, so it will be 36 positive, and we have only positive. So I will collect this one together, and I will collect this one together in two brackets, so it will be something like that. So I gathering x square or x, all x's together and all y's together. One more step forward, that this 9 and 36y and this y square, so I got a common factor y, 9, and this one I got common factor 4. So now I isolate x square, just only x square. Now you are in a right way and in a right step to get the formula. Okay, right now we have here this one and this one, but still having x and having y. I need to remove that one. I need to simplify that one. It will be x square and y square, just only x square and y square without x and y. So I have to diminish this one. I have to eliminate this one. So I will do one step forward. That means I will make completing the square in x and y in result of. So that's what mean I will increase 36 and subtract 36. So it doesn't mean anything for me right now. And if you look at that one, that I add 9 and I subtract 9, doesn't mean anything for me. So what happened right now? So I have 9 with that bracket and 4 with that bracket, because that's 36 also. So we have here 36, new 36, and I'm having here 36 over there. So that means I add over that 36 and subtract 36, and subtract here 36 and I add 36. So never happened anything, right? So again, that part still the same, but if I add here 4, that means I add 36. So but it will be negative, so I will add positive 1. So it will be 36 minus and 36 positive, so nothing happened. Here, to get this 9 inside, it will be positive 36. So I will have negative 36 here. So negative 36 plus positive 36, it will be nothing over there. So everything it will be again like that. So what we have here, we add and subtract, so still everything is the same right now. Okay, so this one, it will give me what I wanted to get, and this one, it will go out this with this, and it will have this one what I get here. See what it will be here. Okay, so now x plus 3 square 9 y minus 2 square. That means we moving that x with 3 and we moving that y with 2, and divided by 36, you will get our equation. So the center of the parabola is the point negative 3 and 2, and our cutter axis length, it will be 2a, it will be 6, and the other length companion, it will be 4. See, that's what happened. I move that negative 3 and I move that 2 positive for y. So our negative 3 and 2, and our axis here, the matrix, it will be 2a over e negative 3, and here negative 3. So everything it moves from that part to that part, so everything it will be negative. The approximate line of the hypothesis, it will be the approximate the touch hyperbolic hyperbola at infinity, and this characteristic that is unique to hyperbolic from both parallel and the ellipse. See something like this one, those two tangent lines. So our equation, it will be something like that: x square over a square, sorry, this one, it will be y square over b square equal two approximate lines, and y, it will be b over a x, and y it will be equal b over a x, and this one will be negative and this one will be positive. Finally, existing parabola, that what we have here generally, the general equation are straight line, and both straight line, these equations of them. The two inclination are respectively that inclinations or slope, first slope that one and second slope that one. That means you look this, that one it will be the first slope, and that one it will be the second slope for those two lines. The approximate line or coordinate are that multiplied by each other, and it will be should be, because perpendicular, -1. Okay, so a square equal b square, and the two axes in this case combining axes are equal, and both of them are equal. So the hyperbolic that is approximate by orthogonal is called hyperbolic hyperbolicity, in which case the equation of the hyperbolic is this equation. It will be the new one for us. Solving this one right now, solving this equation resulting in the central difference of existing hyperbola being a2 equal square root of 2, that is e equal that. So thank you very much for attending this lecture, and I have to wish you good future for you. I will maybe this is the last lecture, that not maybe, that's sure, this is the last lectures for us with that analytical geometry. برجو ان كل واحد منكم يخش على الموقع، يا ريت تعمل اشتراك في القناة علشان اقدر ابعت لك حاجات تانية، لان ممكن نبعت بعض المراجعات او نحط بعض البي دي افات، خصوصا ان احنا هنبعت بعد كده هوت بعض التقييمات اللي احنا هنتكلم عليها ان شاء الله فيما بعد. برجاء ان انت لو في اي مشكلة ابعت لي على الكلاس روم، ويا ريت يا ريت يحصل في تفاعل بيننا وبين بعض. شكرا for your attending that lectures and other lectures, and we'll see you later ان شاء الله بعد ان ما تنتهي المشكلة اللي احنا فيها ديت بتاعت الفيروس، ويا ربنا ييسر ونرجع تاني نشوف بعض. شكرا جزيلا.